All right. Hello. We are going to do 8-3, 8-4, day 2 today. Again, this is just an extension of what we did on Friday. So on Friday, we talked about the box method for multiplying polynomials, and we talked about the distributing method for multiplying polynomials. Today, we're doing the same thing, except instead of just doing 2x2s, we'll do 2x3s and 3x3s. Again, when I say 2x2, I'm referring to the fact that this has two terms and this has two terms. So today we'll do something with three terms, and so on and so forth. Okay. I will demonstrate both methods, so I'll do a bit of the box and I'll do a bit of the distributing method. Okay. So let's take a look at this one first. It'll probably be the easier one. So again, there's two ways I can do this. I can do this by distributing or by the box. I'll do the box method first. So again, one side of my box will be x plus 3. It doesn't matter if you make it the top of the box or if you make it the side of the box. So again, what I'm saying is you could put x plus 3 on the side, in which case you'd have more of a longer left and right shape, or you could put it on the top, in which case you're going to have more of a taller shape. It doesn't matter. You'll get the same thing either way. Okay, so I put x plus 3 on the top. To the side then, I'll put the x squared, the plus 5x, and the plus 2. Okay. Again, I'm drawing the lines for my squares in between each term. So in between the x squared and 5x, I draw a line. In between the 5x and the 2, I draw a line. In between the x and the plus 3, maybe I should separate these a little more. I draw a line. And you'll, of course, notice that I have 6 boxes because I am multiplying two things by three things, two terms by three terms, which makes 6. Okay, so again, in each of these boxes, I'm now going to multiply corresponding parts. So I'm going to multiply x and x squared to get x cubed. I'll multiply x and 5x to get 5x squared, x and 2 to get 2x, 3 and x squared to get 3x squared, 3 and 5x to get 15x, and 3 and 2 to get 6. I'll then write this all out. Sometimes it's also not a bad idea to cross off the boxes as you do them, just to make sure that you didn't leave anything back in your square. I guess in this case a rectangle. And then I'm going to combine like terms. Again, reminder that when we're combining like terms, we need to switch gears from doing exponent rules to doing combining like terms, addition rules. So I'm not going to add exponents here. 3x squared plus 5x squared is 8x squared. 15x plus 2x is 17x. And then, of course, I have that plus 6. Okay? So that is a 2x3. Again, here's another 2x3. This one's a little more complicated. I've got double variable. Doesn't really change anything though. I'm still going to do it the same way. Again, I could do this with the box, or I could do this by distributing. I'm going to demonstrate this one with distributing. So I'm going to do 3x times 5xy. So the 3 times 5 is 15. And then I have xy, so that's x squared y. I'll then do the 3x times 3x squared y. So again, 3 times negative 3 is negative 9. X squared y would be x3y. And then 3x times the 6xy is going to give me 18 x squared y squared. I'll then multiply everything by the plus 4. So I'll have plus 20xy. I'll have minus 12 x squared y, and 4 times 6xy squared, I'll get 24 xy squared. Okay, from here, I'm going to go and I'm going to look for like terms for things that can get put together. I can put these two together because they're both x squared y's. Sorry, I'm just double checking my work. And then none of the other ones I could put together because they do not have matching variables and exponents. So I'll put those together and I'll make 3x squared y. Everything else I'm going to write down. I guess if I'm doing standard form, I would probably put the minus 9x3y and then the 18x squared y squared. I'll put the plus 3x squared y. I should probably cross off who I've done so I don't mess up, but plus 24 xy squared plus 20y, xy. Okay. So again, that's the distributing method. That's the only time I'm going to do the distributing method today. I'm really going to recommend that you use the box method. I think it's much cleaner and easier to do. So let's do one more with the box. Let's do a 3 by 3, and then let's talk about this power 3, and then I'll very quickly go through special products. Okay. So which one do I want to do? I think I'll do this one here. So again, here I've got 3 terms by 3 terms. So I'm going to end up having a 3 by 3 box. So I should end up with 9 squares. Again, it doesn't matter which one I put on the top of the box and which one I put on the side of my box. I always just put whichever one comes first on the top, whichever one comes second on the side. So this top of my box, the side of my box, I'll put the x squared, the plus 3x, and the plus 2. Again, now I'm drawing the lines for my box in between the terms. So in between the x4 and the 2x squared, I draw a line. In between the 2x squared and the plus 6, I draw a line. In between the x squared and the 3x, I draw a line. In between the 3x and the 2, I draw a line. When I close the outside of this box, I have 3 by 3. I have 9 squares, which is what I would expect, right? So again, now I'm going into multiplication when I do the box, so make sure I'm multiplying the numbers and adding the exponents, which is why when I do x2, x4, I'm going to get x6 because I'm adding the exponents there. x2 times 2x squared is 2x4. X squared times 6 is 6x squared. x4 times 3x is 3x5. x4 times 2 is 2x4. 2x squared times 3x is 6x3. 6 times 3x is 18x. 2x squared times 2 is 4x squared. And 6 times 2 is 12. Okay, so let's write this out. And as I'm writing it out, I could combine like terms like as I write it out. But certainly as I write it out, I'm going to try and write it in standard form. So I'm going to start with x to the 6. Then I'll write the 3x5. Then I have those two x4s. I have 2 of them. And then I've got the 6x3. I've got the 6x2, the 4x2, the 18x, and the 12. Yes, it is a lot, isn't it? I'm going to double check that I've got 9 terms. Here's 3, here's 6, here's 9. Okay. Then I'll combine like terms if I have any, in which case it looks like these guys can get put together. So I have x6 plus 3x5 plus 4x4 plus 6x3 plus 10x2 plus 18x plus 12. Wow. Okay. Hey, a reminder that when I combine like terms, again, I'm only adding or subtracting the coefficients. I do not do anything with the variables. So 2x4 plus 2x4 is 4x4. Don't accidentally say 4x8. Okay, last thing I want to talk about, well, not the last thing. Second to last thing I want to talk about is this x plus 5 cubed. And then again, I'm going to talk about these special products. This is optional. You don't have to do it. So x plus 5 cubed. Again, the cubed would mean that you write this out 3 times. What you don't want to do here is you don't want to try and multiply all 3 of these at once. You don't want to like do this and this Don't do that. Okay, it's similar to like if you're doing 5 times 6 times 3, you don't actually times the 5 to the 6 and the 5 to the 3. Okay, if you're doing 5 times 6 times 3, you would multiply these one at a time and you would get your answer that way. So that's what we're going to do here. Do not try and do the Punnett cube. I don't care how much sigma aura you think you have. That's going to be too messy. So I'm going to multiply these two at a time. So I'll start with these two. So I'm going to do x plus 5 times x plus 5. Then from there, I'll take my answer and I'll multiply it by the last one, okay? So this makes x squared plus 5x plus 5x plus 25. So I'm going to write that out. That makes x squared plus 10x plus 25. Now what I'm going to do is I'm going to take that x squared plus 10x plus 25 and I'm going to multiply it by my last one. So I'm going to take x squared plus 10x plus 25. I'm going to multiply it by the other x plus 5. So again, I'll set up another Punnett square here. So on the top, I'll put x squared plus 10x plus 25. On the side, I'll put x plus 5. And I'll multiply this out. So x2 times x is x3. x2 times 5 is 5x squared. 10x times x is 10x squared. 10x times 5 is 50x. 25 times x, 25x. 25 times 5 is 125. And if I write that all out, I'm going to kind of combine like terms as I go. So x3 and then 10x squared plus 5x squared is 15x squared. And then 25x plus the 50x, 75x. And then 125. So again, trick for this is to just work 2 at a time. Don't try to do the whole thing at once. Do 2 at a time. Whoops. Okay. 8-4 is on special products, which really introduces 2 formulas, which I'm going to show them here and explain them. But you don't have to use them, and I actually think it's probably more work to memorize the formula and recognize that you have one of these special problems than it is to just actually multiply the problem out with like a Punnett square. So the first formula is if you have something that is of the form a plus b squared, if you multiply out a plus b squared, like you do it twice, you're going to get a squared plus 2ab plus b squared, okay? This gets you 1ab, this gets you the other ab, this gets you b squared, this gets you a squared, and yeah, that square, you get that, okay? So again, if this part makes no sense to you, ignore it. You can multiply this by like normal. So for example, if I have x plus 5 squared, I can certainly do this my Punnett square way and get x squared plus 10x plus 25. The other way I could do this is, again, this would be like my a and this would be my b. So a squared would be x squared. 2 times a times b, that's this right here. 2 times a times b would be 2 times x times 5. Well, 2 times x times 5 would be 10x. And then my b squared, which is my 5, would be 25. Okay, this only works for something where it's a plus b squared. Okay, so again, here I have 4x plus 3 squared. I could multiply this out with the Punnett square, which is probably how I recommend doing it, so you don't have to memorize this formula. But I could also recognize that this is of the form a plus b squared, where a is the 4x and b is the 3. So a squared would be 4x times 4x, 16x squared. 2 times a times b, well, a times b would be 12x, times 2 would be 24x, and b squared would be 9. Okay, again, you don't need to memorize this. You could, if you're like, I'm going to ignore that. This makes no sense, Mr. Smith. You could just make your box and do it this way. Okay, so again, this would be 16x squared. This is 12x. This is 12x. This is 9. Put that all together, you get the same thing, right? The other formula here, this one we will actually use a little bit more when we do factoring, as if you multiply something of the form a plus b times a minus b, so you have the same numbers, the only difference is one is plus and one is minus, that this actually simplifies to a squared minus b squared. Okay, basically this is going to give you a plus ab, this is going to give you a minus ab, that middle term that you would get like these guys right here It'd be nice if my screen was not jumping all over the place from the edge of my jacket touching the touchpad. But basically, these two guys right here are going to cancel, and so you're only left with the corners, which are the a squared and b squared part. Okay. So again, if I wanted to do this problem, I recognize that, hey, this is the same thing. It's just that one is plus and one is minus. This would simplify to x squared minus 16. A squared, which is the x, would be x squared. B squared, which is the 4 squared would be 16. So this is x squared minus 16. Same thing here. I could recognize that, hey, this is the same thing twice, just one is minus and one is plus. So the shortcut for this is a squared would be 2x squared. Well, 2x squared would be 2x times 2x, which is 4x squared. And b squared, which is the 3, well, 3 squared is 9. So this would be 4x squared minus 9. Again, you are more than welcome to memorize that formula and use that formula, but you're also probably more likely to, and probably the better option, is to ignore the formula, multiply it out with your Punnett square, get the same answer anyways, and not waste your time with that formula. So again, if you notice, these would cancel and you'd get the same 4x squared minus 9. Okay, I've got the homework posted in the notes. I'll highlight some right now. We certainly don't need to do all of these. I just want you to try a few of them. So let's say that we do a 2 by 3. Let's do a 3 by 3. And let's do another 3 by 3. And one, say, like this. Actually, let's go back. Let's cut off one of the 3 by 3s. So let's do that. And then if you want to try, no, never mind. You know me, guys. It wouldn't be a true Mr. Smith class if I didn't backtrack 10 times. Let's do these ones. Okay, do those 5 for me, and then we will call it good. I will check homework when I come back. Thank you.